This is going to be our review for the Unit 1B test, which will be coming up very soon. So make sure that you guys study this. This is the best thing that you guys can do to study for this coming test. So make sure that you guys do that. So the first learning target that we have is I can draw the image of a figure after a translation along the vector. So with this video, just go ahead and try out each problem on your own, and then you'll be able to see me work through it afterwards. Of course, if you've already gone through them all, then just watch through it once again if you need to. You don't need to continue doing the same problems over and over. So our first problem is to draw the image of the vertices of triangle DEF along the translation vector. So we have vector A here, that's our translation vector, and we're moving each of these points in triangle DEF along this vector. So this vector is going to the right 4 and up 2. Again, we have our initial point and our terminal point at the end of the arrow. So I move each of these points to the right 4 and up 2. And when I do that, we should have a new image. So here is our new image, D prime, E prime, F prime. So D prime is at 5, 3, E prime is at 8, 5, and F prime is at 6, 6. Now, if you are just going to draw, you're just going to draw the vertices. I just need those points. However, if they ask you for the coordinates, then you'd write out each of these coordinates. So keep that in mind. It may ask for the coordinates, or it may ask you just to draw the vertices. All right. Next up, specify the component vector that maps triangle ABC to triangle DEF. So for this one, I know that A will be mapped to D, B will be mapped to E, and C will be mapped to F. So order does matter when we're listing these. A goes with D, first goes with first, second with second, and third with third. So I want to map A on top of D, and we want the component form of the vector. So component form means pointy brackets. So I want those pointy brackets. So get from A to D, I need to move right 1, 2, 3, 4, so that's positive 4. And then we're moving down 1, 2, 3, so that'd be negative 3 because I'm moving downward. So our component form for this vector is the vector 4, negative 3. All right, so a translation vector maps points in quadrant 1 to points in quadrant 4. What can you conclude about x and y? Now, if I were to draw out the quadrants, we of course start in quadrant 1, which is the top right, and then we move in a counterclockwise rotation to find out the rest of the quadrants. So we have 2, 3, and lastly 4. So if I'm moving a point in quadrant 1 to a point in quadrant 4, and I want to know about the x and the y values. So looking at this, I need to move right for my x values or small enough negative numbers so I do not cross our y-axis. We cannot cross this axis. Because if I do, then I'd end up in quadrant 2 or quadrant 3. So the x values either need to be positive or they need to be negative, but small enough negative numbers that we do not cross the y-axis. As for our y values, well, if I'm moving to quadrant 4, my y values must be negative values. So again, the x coordinates are positive or small enough negative numbers that we do not move through quadrant 2 or 3. Meanwhile, our y values are negative to move us into quadrant 4. So they need to be negative enough that we move all the way down into that quadrant. Our next learning target is I can draw the image of a figure after a reflection over a line. So we have this blue line here. We want to reflect figure ABC across of it. So go ahead and pause the video if you'd like and try this one out on your own, and then we'll continue on after. So looking at this line, this is the line y is equal to 1x plus 0. Keeps jumping. 1x plus 0, which is also the line y equals x. So these two are the same exact line. Now, we have a rule for reflecting across the line y equals x, and that rule is xy turns to not negative y, but just y, comma, x. So I just flip my x and my y values. They just flip places. So looking at point A is at 1, 3. So A prime should be at 3, 1. Oops. I went too far. I went 3, 2. 3, 1 is right here. So there's A prime. B is at 2, 6. So therefore B prime should be at 6, 2. And C is at 4, 5. So C prime should be at 5, 4. So we now have the image of our vertices of triangle ABC after reflecting over the line y equals x. Now again, I just need the vertices. I do not need the actual lines connecting them. The vertices is all you need for these types of problems. Now, on top of that, if I needed to find out what line this actually is, well, I can see that my y-intercept is 0 here, so that's where this 0 comes in. And then I can use rise over run to find out my next point. So I can see that I rise 1 and run 1, so my slope should be 1 over 1, which is where this 1 comes in, because 1 divided by itself is, of course, 1. Now, of course, if there's a 1 in front of a variable, I don't need to write it, so I can just make that 1 disappear, and I can drop a 0 if I want. So this is the same as y is equal to x. So just keep that in mind as you go through. I won't give you anything that's like reflect over the line y equals 2x plus 7. I won't give you guys anything like that. That won't happen. But just keep in mind, you will see, if you see diagonal lines, it's either going to be y equals x or y equals negative x. So just keep that in mind. All right, next up, I can determine the equation of a line of reflection when given a pre-image and image. So for our equation is going to be in slope-intercept form, which is y equals mx plus b. So when you guys run into this problem, you'll see y equals blank times x plus blank. You guys will need to fill in the two blanks, the slope and the y-intercept. Now, even if you have a negative y-intercept, I'm still going to put the negative in there, even though I see a positive here. So make sure that you put the negative if it is a negative number. If it's not, then just put a positive number and that's fine. But make sure that you guys do put these numbers in here and make sure that you include the negatives as well as, even though there is a positive right here. You don't need to include positives. I don't need to write like positive 2. You don't need to do that. All you need is the 2 if it's a positive number. If it's a negative number, include the negative. All right, so write the equation of the line of reflection in slope-intercept form. So go ahead and pause the video if you'd like. Try this one out, and then we'll do it together. So, looking at this, we have a couple steps that we can do. My first step is to draw the segments from pre-image to image. So I draw my segments. Now I only need 2 segments here. I don't need all 3, but if I want to do all 3, I can. But to save time on the test, I'd recommend only doing 2 of them. You don't need to do all 3. The next step is to draw the midpoints on my new segments. Now we do have the midpoint formula to make sure that we're accurate. You can use this. But I can see that my midpoints are right here and right here, as well as right here. So I can see that 2 points will create that line for me, but I can use 3 just to maintain accuracy. And then from here, I'm going to go ahead and draw my line through my points. Oops, wrong line. So I draw my line through my points, and we have this blue line here. This is our line of reflection. So this is the line of reflection. Now, at this point, now that we have our line of reflection, all we have to do is find the slope and the y-intercept of your new line, of this blue line. So looking at this, my y-intercept is where we cross the y-axis. That's at 0, 4. It's my b value. And then my slope I can find by using rise over run. So to get to my next point where we cross the line perfectly, I can see that that happens down here at my x-intercept. So I can say I can rise down -4 and run to the right, +4. So my slope is equal to -4 over +4, which is equal to -1. So that's our slope here. So therefore, our equation is y is equal to -1x plus 4. So that is our equation for this line of reflection. And again, just follow these steps and you'll have your equation for the line. Here it is in another color. Again, these segments are being bisected by our line of reflection, and then this is more color coordinated in terms of the answer even. All right, next up, write the coordinates of the image after reflection over the line x equals 2. So the line x equals 2 is right here, this blue line. Go ahead and pause the video if you need to, that way you can work on this one as well. If I'm reflecting over the line x equals 2, to find this line, I'm on my x-axis. So I go over on my x-axis to 2, and then no matter where I go, if I go straight up and down, x will always be 2, no matter what y is. So this will be a vertical line for us. Now, if I need to find out what my image is, it should be the same distance from my pre-image to my line of reflection as it is from my line of reflection to my image. So if B is 1 unit away, B prime should also be 1 unit away. So B prime is the point 3, 3. Again, we're looking for the coordinates here, so I'm going to list out all my coordinates. C is 1, 2, 3, 4 away, so C prime is also 4 away at the point 6, 6, 2. And then A is 1, 2, 3 away, so A prime should also be 3 away. So A prime is at the point 5, -4. So those are my 3 new points. Now again, we can come up with our rule for this of xy changes to -x plus 4, comma y. And then we could have plugged in each of our points and gotten it that way as well. But for these ones, when you can just count very easily, you can just count. You don't need to worry about having everything perfect and doing the exact rule or anything, but you can just count for these as well if you need to. So again, here is our final image, and we can see, oh, it's 1 and 1, 4 and 4, 3 and 3. All right, next up, you're going to reflect this figure across the line y equals -x. What I want to know are the coordinates of the image. So we want to find the coordinates here. So to do this, we have a rule for reflecting across the line y equals -x. And again, that line, y equals -x, is just the same line as y is equal to -1x plus 0. So my y-intercept would be 0. My slope is -1, so it's this red line here. This is our line of reflection. This is what we want to reflect across. Now, when we do this, we have a very special rule for this, and this rule will help us in solving for these points very easily. Our rule for the line y equals -x is that xy changes to -y, -x. So not only do they flip spots, but they also are both negated. They also are both multiplied by a negative. So now I'm going to go ahead and find each of my original points. A is at -3, 4. B is at -5, 2. C is at -1, 2. And D is at -1, 5. I go ahead and I start plugging these in. So A was at -3, 4. So therefore A prime should be at -4, 3. B is at -5, 2. So B prime should be at -2, 5. C is at -1, 2. So C prime should be at -2, 1. And lastly, point D. D starts off at -1, 5. So D prime should be at -5, 1. So these are our 4 new points. Now again, if you know your rules, you can just plug them into this rule, and you can just go right ahead and solve. If you don't know the rule, then of course you'd have to probably count. So, to see that, I can see that I am half a block away, diagonally, from our line of reflection, so our image will be half a block away as well, so A prime is right here. B is 1.5 away, so B prime is 1.5 away. I can see that C is half away, so C prime is half away. And lastly, D is 2 away, so D prime is also 2 away. So these are our new coordinate points. I can determine the line symmetry and rotational symmetry of a figure. So, first off, find the angle of rotation for the transformation of the pre-image to the image. So, for this one, we have triangle DEF mapping onto triangle B, let's see, A, C. So D has to go with B, E goes with A, and F goes with C. Now, if I run into a problem like this, what I need to do is I first need to take my center of rotation, in this case it's point G. I'm going to draw a line segment from my center of rotation to both my pre-image and its corresponding point on the image. So D is on my pre-image, its corresponding point on my image is point B. So I now have this angle here. Now at this point, I'm going to go ahead and take my protractor, and on the test you guys will have boxes over on the side. One of them will be a protractor box, so you'll just have a bunch of different things, calculators are over here and whatnot. And then there's a protractor. Now a protractor kind of has this shape over here, and when you take out that protractor, you're going to lay the flat end on one of the sides of your angle. Now when you do that, it's going to have this curved part going all the way around, so it's going to look something like this. Now, when it comes to something like this, you're going to go ahead and read that angle measure. And when you read that angle measure, it's going to give you two different numbers, either 120 or 60. Now we have this curved part here that we're going to be checking. This curved part is going to have all those numbers on it. So I look at my angle, and we got to determine whether this is 60 degrees or 120 degrees. Now, to do that, just think, is this an acute angle or an obtuse angle? Obviously, this is an acute angle, so we can automatically say this is 60 degrees. Now again, the flat part goes along the ray itself that creates the angle, and then the curve will tell us exactly what the angle is. Just look for that other line that makes up the angle itself, which is this line right here, this red line. So you're just going to be looking for that angle measurement, and the protractor will tell you exactly where it cuts it. Then just keep in mind whether it's obtuse or acute. All right. In the instant a firework explodes, it bursts into a circular pattern equally spaced apart. What is the angle of rotational symmetry of the firework to the right? So what we're looking for here is the rotational symmetry from one point to the next. So we're just looking for just a small rotation here. I'm not looking for the whole thing, but just the degree that we're moving from one angle to the next. Now, to do this, we first know that there is 360 degrees in a full circle. So we take 360 degrees, and we divide it by the congruent parts. So we go ahead and we count up how many parts we have, and we can see that we have a total of 19 in this full circle. So that's 360 degrees divided by 19 congruent pieces, which gives us about 18.9 degrees. So for each turn here, it's about 18.9 degrees. And when you're doing this, just make sure that you're looking for congruent parts, and we're only trying to find one turn. It'll always be 360 degrees because we're always going in a full circle no matter what. All right. Next up, draw all possible line symmetry and state the angle of rotational symmetry. So with this one, we need to draw the line symmetry and count how many lines we have. Now with this, we need to be careful that we're not crossing over and having something come off the side here. We don't want to have that. We want everything to fold perfectly on top of the other side. So with this line, we can see that we have only a couple lines here that will work. This first one is the y-axis. Just go straight up, and we can see if we fold over this purple line, it will fold perfectly on top of itself. The second one would be our x-axis. So we can see that if we fold over this blue line, it would also fold on top of itself. Now, some lines that wouldn't work would be like some diagonal lines, as I can tell that this wouldn't fold perfectly on top, and same going the other direction. These ones would not work, so we'd have to stick with these two. Along with this, this should be the total amount, but for our rotational symmetry, we're just going to choose any point on our figure here. We're going to see if we can rotate it so that it maps perfectly on top of itself once again. Now, again, this needs to rotate perfectly on top. If it's not perfect and there's any part that's hanging off the edge, then it is not rotational symmetry. So, with this, it looks like point C would map all the way over to point L, because these sides do look rotationally symmetric, so we should be able to do that. Now, another way that you can do this is we have 360 degrees in a full circle once again. Anytime that we're talking about rotations, we're going to be using 360 degrees. And if I have a full 360 degrees in that circle, well, I have two congruent parts of this. So I can see that I have the top part, and that's congruent to the bottom part. There's no sides that are congruent, really, for this to work. So we have two congruent pieces, the top and the bottom. So I'm going to take that 360 degrees divided by 2 congruent pieces, and that'll give us the answer of 180 degrees. So a full rotation of 180 degrees will map point C onto point L. Now, along with this, just keep in mind that our angle needs to be between 0 degrees. It needs to be less than 0 degrees, but it needs to be greater than or equal to 180 degrees. So this works. It's right on the edge of our limit. This is the max amount that we can actually go for a rotational symmetry. And of course, this is just an angle measure. That's all this variable is for angles. Now, on top of that, if we had something like, triangles all the way around, then of course we can see that we have more lines of symmetry going through this as well as we'd have 90-degree rotational symmetry on this one, where we can rotate 90 degrees because we have 4 congruent parts this time. So this would be 360 degrees divided by 4, which gives us 90 degrees. So that's just another quick example in here, this green figure. But just know that you will see things like that on the test, and our angle of rotational symmetry needs to be in this range. If it's out of that range, then it no longer works for us. All right, next is our next learning target. I can write the algebraic rule for the rotation and write the transformation in words. So we have these two figures here. We want to write the algebraic rule for the reflection and write the transformation in words. So I'm trying to reflect A, B, C, D onto H, G, F, E. Those two pieces are going to reflect on top of each other. Now, looking at the orientation, they are a bit different. And if I reflect over the y-axis, if I reflect over the y-axis, my figure will just end up over here, with A pointing outward in this direction. If I reflect over the x-axis, this line here, well then my A will be pointing out in this direction. So I can't do a reflection in either of those ways. So I'm going to have to reflect over a line. Now our two lines is y equals negative x, y equals negative x, which is this red line here, or y equals x, which is this blue line. Not that one, but this one, this blue line here. I can do better than that. There we go. So we're going to reflect over this blue line, y equals x. That would map this figure, ABCD, perfectly onto HGFE. So we need to write this in words and write the algebraic rule. Now in words, it'd just be ABCD maps onto, that's what the arrow's for, maps onto HGFE as a reflection over the y-axis, not the y-axis, as a reflection over the line y equals x. As a reflection over the line y equals x, which we can see right up here. Now, if we want to write our algebraic rule, that deals with our x and y values. So that's the xy transforms to what? Well, in this case, I can just take two random points here. If I take point B, and point B corresponds to point G. Well, point B is at negative 2, 4. Point G is at 4, negative 2. Let's just see what happens. If I take point G, it's at negative 2, 4. What happens when it turns to point G? Well, these just flip around. Negative 2, 4 becomes 4, negative 2. So xy turns into yx. So that is our algebraic rule for the reflection over the line y equals x. All right, next up, our final learning target. I can identify and describe a sequence of transformations, which is also known as a composition, that will carry one figure onto another. I can also perform a sequence of transformations and show congruence by using a sequence of rigid transformations to map one figure onto another. So these are the three final learning targets of this test. Draw the final coordinates of each vertice after the series of transformations. So when you're going through this type of problem, I only want the final coordinates. I don't need your middle image, I just need the final image. So we're going to take triangle ABC, this triangle here, and we're first going to reflect it over the line y equals negative 1. Well, y equals negative 1 is this line down below. It's this solid line down here. So if we're going to reflect over this line, y equals negative 1, well, I can just count. I see that B is 2 points away from our line of reflection, so B prime must be 2 points away from our line of reflection. I see that A is 4 away, 1, 2, 3, 4, so A prime should also be 1, 2, 3, 4 away. And lastly, I see that C is 1, 2, 3, 4 away, so C prime is also 4 away. So I now have my middle image. Oops, that's not a really good line. There we go. A little bit better. So we have our middle image. Now we're going to translate over the vector 2, negative 3. So I'm going to take each point and I'm going to go right 2 and down 3. Right 2, down 3, right 2, down 3. So we now have our final coordinates, and these are the coordinates that I want. And again, you only need the vertices if you're drawing. I don't need to draw the actual lines between them. I just need the vertices because I understand drawing the lines is a little bit more difficult on these computers. So A double prime will be the point 4, negative 8. B double prime will be the point 3, negative 6. And C double prime will be the point 9, negative 8. So those are our final points. And again, all I need is the final points. Don't give me anything else. I don't need the blue. If you put the blue on there, that's fine. But just know if you're going to draw multiple figures, do different colors. That way I can distinguish which one's which and know what you're talking about. All right. Find the coordinates of the image after this series of transformations. So go ahead and pause the video if you need to, and then we'll work through it together. All right, so for this type of problem, I'm going to go ahead and take each of my points, and I'm going to find and label them first. So I'm going to take A, B, and C, and I'm just going to label them. I can see A is at 1, 1, B is at 2, 2, and C is at 4, 1. From there, I'm just going to go ahead and label those underneath. So I'm going to put A, which is 1, 1, B, which is 2, 2, and C, which is 4, 1. Now we got a series of 1, 2, 3 transformations. So what we're looking for is A triple prime, B triple prime, and C triple prime. So we need to find each of these points here. Now, to do this, I'm just going to go ahead and run it through this transformation series. So first off, I take A, which is at 1, 1. If I'm doing 2x comma negative y, I'm going to multiply my x value by 2, multiply my y value, and just negate it. So I now have 2 comma negative 1. Next, I go ahead and I move it into my next transformation. That's x minus 3, y plus 6. Well, 2 minus 3 is negative 1. Negative 1 plus 6 is positive 5. We move into our final transformation. So that means multiply my x value by 1/2 and take my y value and subtract 2 from it. So that will give me negative 1 times 1/2 is negative 0.5. And then 5 minus 2 will give me 3. We go ahead and we move into our next one. I take 2, 2, do the same thing. 2 times 2 is 4, negative 2. Move into my next transformation. 4 minus 3 is 1. Negative 2 plus 6 is 4. Move into our final transformation. Take my x value, multiply it by 1/2. 1 times 1/2 is 0.5. 4 minus 2 will just give me 2. Then my final point is point C. This will give me 8, negative 1. This will give me 5, 5. And moving into our final one, this will give me 2.5, comma 3. So these are our final points. These are the points of our final image, and this is what we'd be looking for as our answer. Negative 0.53, 0.52, and 2.53. So it'd be this green triangle right here. All right, next up. Here it is with all 3 images as well. If you want to see the transformations, you can also do that. can take each point. Granted, this will take longer. So if this is easier for you, of course, do it, but I would probably save this question for last if you're going to do it this way, because this problem will take a little bit more time if you're going to be drawing it. So just keep that in mind. All right, this is our final one before we do our challenge problem. So find a sequence of rigid motions that maps the pre-image, DEF, triangle DEF, to its image, triangle ABC. All right, go ahead and pause the video if you need to, and then jump back in whenever you're ready. So for this one, I'm going to take triangle DEF, I'm going to take triangle DEF, and I'm first going to notice that the orientations are different, meaning that I must do a reflection or rotation. In the case of DEF, I'm going to go ahead and do a reflection. I'm going to reflect across the line x equals 3. So that's this purple line here, x equals 3. And the way I know that, if I go to 3 on the x-axis, it should just be a vertical line straight up and down. That's x equals 3. So I go ahead and I take DEF and I reflect it across that line, and it will give me this purple triangle right here. Triangle D prime, E prime, F prime. Whoops, I need to get rid of one of those. There we go. So we now have our new purple triangle. From here, well, they now have the same orientation, so we should just be able to do a translation. So I'm going to go ahead and translate F prime to C prime. And the reason I do that is because F corresponds with C. I could have done D prime to A prime, and I also could have done E prime to B. It doesn't matter. You just choose one, make sure that they're corresponding. So if I look at this vector, I need to move to the right 2 and up 4. So I move along the vector 2, 4. So again, just to recap, that was a reflection followed by a translation, a reflection over the line x equals 3, as we can see right here, and then a translation along the vector 2, 4, which we can see right here. And then if I want to write it out as a rule, we can see the rule for the reflection and the translation. If I were to put them together, we should all have the same answer if we put all of ours together, even if you do different steps than me, because again, you can do different steps here if you'd like. I have xy turns to negative x plus 8, comma, y plus 4. So this is our rule to get DEF onto ABC. No matter what, this one will work. And in fact, no matter how many transformations I did, if I were to combine them all down into one, I would get this as my final answer. All right, now we're going to talk about the challenge problem. So the challenge problem deals with 30, 60, 90 triangles. We haven't talked about this in class. I wanted you guys to kind of look it up and see what you can find out about it, but this is it. As you can see, the 30, 60, 90 triangle is named by its angles. 30, 60, and 90. So, some unique things about this. Now, this triangle will always be proportional to any other triangles that have the same angles. So no matter how big or small they get, the side opposite 90 degrees, meaning this side over here, will always be double the side length opposite 30 degrees, this side length over here. So this side length will always be double the length of this side length, always, in a 30, 60, 90 triangle. Likewise, the side opposite 60 degrees is always the length of whatever the side opposite 30 degrees is, x, so whatever you find out x to be, it'll always be this length multiplied by radical 3. So in fact, if I can find out any of these side lengths, I can find out the rest of them, which is really nice for 30, 60, 90 triangles. So we're going to use this in order to find out the coordinates of these propellers. So if we look at this, I have 3 propellers here. I can see that the propeller on the axis is labeled at the final point of 6, 0. Now what I want to find out is this point right up here and this point right down here. Now, to begin, we know that there's 360 degrees in a full circle. I have 3 congruent pieces here, so I know that there is 120 degrees between propellers. So between each propeller, there's 120 degrees. Now, I'm going to use my axis as my marker, And that also allows me to use that far edge point as my marker, meaning that the angle that's created by these purple line segments, this is my 120 degree angle. And I wrote that kind of far up there, that way we can kind of see more of what's going on. Now, another thing that we can note about these axes is that the x-axis and the y-axis will always intersect at 90 degrees. So this is already 90 degrees right there. Now, if I use the angle subtraction postulate, I can do 120 minus 90 to give me this last angle here, which would be 30 degrees. Let me do this in blue. This would be 30 degrees. So this angle here is 30. Now that leads us to my first hint, the 30, 60, 90 triangle, right? We're talking about the 30, 60, 90 triangle. This isn't drawn to scale. We now can create one of these. So as soon as you see 30, you should be thinking, oh, maybe I can create a 30, 60, 90 triangle. Now, I know that the blade length is 6. So does that mean that every blade length is 6? Well, yes. If the blade lengths aren't the same length, then it's going to fall apart. It's the same as if you took off one of the blades of your fan will start rattling and shaking and then eventually fall apart. So it needs to be spread out evenly, and they need to be the same length and weight. So I know that this is length 6. So I can go ahead and put that. This is 6 in length. Same with this other propeller blade. This is also 6 in length. So they're all congruent. Now, I also know that when I created this triangle, I made a 90 degree angle at my at my y-axis. So this angle is 90 degrees up top. So the side opposite 90 degrees is equal to 6. Let's go over here to our triangle. So the side opposite 90 is 6. So 2x is equal to 6, which means x is equal to 3. So this side length over here is 3. So I know that this length up top is going 3 in length. So on the coordinates, of course, it's negative 3. Because it's going in a negative direction. As for our side length that's opposite 60 degrees, which this would be 60 degrees, right? 30, 60, 90. That side length would be equal to 3 radical 3. Because again, if I know x is 3, and I know the side length is x times radical 3, well then that'd just be 3 radical 3. So therefore, this side length is 3 radical 3. So our coordinate, we have the coordinate 6, 0 already from our start. We now have the coordinate negative 3, comma, 3 radical 3. And then for our final coordinate, well, I've already gone 30 degrees in. And to get out of this next coordinate, out of quadrant 2, I need to go 60 more degrees. So this is another 60 degrees just to get out. Which means to get to the next blade is going to be 60 degrees. So this is also 60 degrees here. Which means I have another 30, 60, 90 triangle I can make. Now, with this 30, 60, 90 triangle, we're going to do the same type of thing. So I already know that this is 60. I created my 90 degree angle, and I can create my 30 degree angle on the bottom here. I know that my side length opposite 90 degrees is 6 in length. We already know that because it's going to be the same length as our original propeller. So therefore this is 6 in length, which means 2x equals 6 again, which means the side opposite 30 degrees, so here's 30 degrees, the side opposite it, this side length, it's on the other side of the triangle, this is equal to 3. Once again, this is 3. And again, we're going in a negative direction, so we'd use negative 3 in this case. Here, let me go ahead and do that in red. Negative 3. As for the side opposite 60 degrees, well, this is just reflected over, right? The side opposite 60 degrees is going to be 3 radical 3 once again. So this side length is also negative 3 radical 3. The reason it's negative is because we're going downward in a negative direction. So therefore, this point would be the point negative 3, comma, negative 3 radical 3. So again, we have the point 6, 0. We have the point negative 3, comma, 3 rad 3. Lots of 3's. And we have the point negative 3, comma, negative 3 radical 3. So those are our 3 points. Other than that, if you guys have any questions, leave them in the comments or let me know. I hope that you guys have a great day. Thank you guys so much for watching. I'll see you later.